Today, we're doing something a little different. I've been very busy recently, changing jobs and moving to a new city, and as a result, did not have time to write a new episode. That being said, I have a lot of pre written Patreon episodes, and today's is going to be one of those. But have no fear, Patreon members, this is also going to be new to you. So without further ado, let's jump in. I've got something pretty cool to share at the top of today's episode, and that would be the ability for butterflies to remember where things are over large spaces. This is super cool, and in an earlier episode, I mentioned how butterflies can also keep memories from when they were a caterpillar. Putting these things together could very well mean that the butterflies you see in your gardens might not be random after all. A recent study was done at the University of Bristol to determine the memory of heliconia butterflies, and what they found is that the butterflies actually have pollen routes which they've memorized and repeatedly returned to. I have a feeling monarch butterflies are doing something similar during their routes to and from Mexico. Of course, it has to be a bit deeper rooted than pure memory, considering the butterflies follow the same general route through multiple generations. Regardless, this is the first time we have quantifiable evidence that butterflies have spatial learning. If you're thinking, what the heck is a heliconia butterfly? They are a tropical group commonly found in Central and South America, but they can also be found in the United States. They're unmistakable once you've seen one, and are extremely common in butterfly houses around the world. Now, continuing on the topic of heliconia butterflies, it was also discovered recently that not all of them see the same colors. In fact, similar to how men often have color blindness, male heliconia butterflies also sometimes don't see the full spectrum of color, and they're limited to tones of light and dark. I don't know what it is with heliconia butterflies lately, but they seem to just be the popular study choice. Basically, some of these butterflies have the ability to see UV light, and within these UV-seeing butterflies, there are species which are visually dimorphic. Simply put, the females have a gene on their sex chromosome which enables them to see UV, while males cannot. This is the first time we've seen a gene like this move to a sex chromosome, and it's pretty interesting. Something else which is incredibly interesting would be the new research going into making biodegradable plastics out of insects. At first, this sounds kinda bad, I admit. Like, are we going to breed insects only to crush them? But thankfully, it's not like that. Essentially, what's happening is that the leftover dead insects from mass breeding projects are getting recycled into plastics which we can use and safely throw away without leaving toxic waste. I know you guys know by now that insect bodies are made up of chitin, which is a strong and flexible carbon-based structure, but now we can use it as a building block to create more tools that we as humans need. Certain countries around the world have already been using chitin from shrimp and other crustaceans, but the chitin extracted from insects like black soldier flies has been tested in the American Chemical Society and seems to be more pure. Also, it's good because it completely avoids potential seafood allergies.
But wait!
It gets better, because as it turns out, another byproduct can be created from the chitin which acts as a super absorbent hydrogel. What's so great about hydrogels? We can use them to protect crops from flooding for one, and then all the water which gets absorbed can be released during a drought, along with other nutrients, considering the gel was made from biodegradable insect chitin. So earlier I mentioned how butterflies keep their memories from being a caterpillar, and now I want to share some new insight into how it's possible, and why insects are now believed to have behavioral decisions similar to other animals, like us. So earlier I mentioned how butterflies keep their memories from being a caterpillar, and now I want to share some new insight into how it's possible, and why insects are now believed to have behavioral decisions similar to other animals like us. For a very long time, insects were believed to react to things like a robot without any real thought. But new research proves that insects make their own decisions based not only on what's in front of them, but also on the current state of the animal. For example, maybe it isn't hungry, maybe it's scared, maybe it wants something completely different. I mean, this can be seen in raising caterpillar. They have food they like, and then they have food they tolerate. It's a vastly different scenario, leading to caterpillars growing exceptionally well to just barely making the cut, because they didn't like what you provided. Basically, the large mushroom-like brain at the head of an insect is where the insect first makes a behavioral decision. Now we're going to move over to Australia, where some really encouraging urban greening projects have been underway. I've mentioned before on this podcast how important it is to have a healthy quantity of plants in urban environments. And of course, having a greater variety is also important. But what are the impacts of increased plant variety in urban areas on insect diversity? Researchers at the University of Melbourne have found a 7 times increase in the number of insect species over the course of 3 years after increasing the diversity of indigenous plants within a small green space. This small green space in Melbourne started out with only 2 trees, a grass lawn, and a handful of species. But after planting 12 different native species, the insect diversity jumped to 94 species, of which most were native. This just goes to show that insects know how to find their food. Speaking of food and plants, it's time for a small botany corner on this episode, specifically talking about orchids. I don't know if you know, but orchids are pretty stingy. They always trap or trick their pollinators and give nothing in return. I would have thought they'd be better than that, considering how long it takes them to grow, and how delicate they are compared to other flowers. But this is not the case. Well, until now that is. A study in Kobe, Japan found that there is one species of orchid which seems to have evolved a change in strategy. This fungus-feeding flower grows fleshy leaves which fall off after fungus-feeding flies have pollinated them. This leaf can support the larvae of these flies, making it a convenient place for them to hang around. Usually, these kinds of interactions result in a codependent relationship, the way many pollinating weevils have their special plants. So this might be the beginning stages of the first codependent insect relationship between flies and orchids. That ends today's special bonus episode. Go to patreon.com/insectsforfun to get a load of other episodes like this for $5. Or you can get video vlogs of my insect antics for $10. It helps support the show. If you don't want to support the show financially, but you listen to it every week, go and hit that star on Spotify or write and rate on Apple. There are over 700 followers of this podcast on Spotify, and only 70 or so ratings. Just tap the star. And Apple is in a similar boat. You have your phone out, just write up, "It's fun." Boom, you're done. All right, guys, thanks for listening, and you'll hear from me again next week.